Alright, I'm back with another video to first off show you my cheeseburger that I was missing from my last video. This is our mnemonic device that we use when we use the standard algorithm. Does McDonald's serve cheeseburgers? Which reminds us to divide, multiply, subtract, check, and bring down. However, we use this for the standard algorithm, and I'm here to show you the partial quotient, so we don't need that right now. So I'm just going to go ahead and make up a problem here. Let's try 759 divided by 6. Okay? To do my partial quotient, I'm going to draw a large hangman looking apparatus and I'm going to X out this area up here because I'm not going to use it. I'm going to try to chip away at this number the best that I can, using things that are easy for me to multiply in my head, because we've talked about division being the inverse of multiplication and multiplication being the inverse of division. So an easy number for me to chip away at this is, I know that 6 times 100 is 600. So I'm going to put my partial quotient over to the side, and I multiplied my partial quotient by my divisor, which got me the 600, and then I subtract. So now I'm left with 159. Again, for my students, I told them we could go ahead and draw our division box again and draw our divisor there if that helps them, but that's definitely their choice. And so now I have 159 divided by 6, and so the next number that I might want to choose that makes sense in my brain might be 20. Because if I were to just look at these two numbers right here, I would be looking at how many times 6 can go into 15. And so I know that 6 times 2 is 12, and that would be closest, because if I did 6 times 3, that would be 18, and I would be going over. And something that I've shared with the children is that you cannot go over, just like on The Price is Right. If you go over, you lose your showcase showdown, and so you want to be under but closest to the number that you're looking for. So that's definitely a reference that I keep bringing up, and luckily most of my students have expressed that they have seen that show, which is pretty awesome. So again, I multiply my partial quotient by my divisor, and I have 120. Subtract. And see, I'm chipping away at it here. My numbers are getting lower and lower. And so now I can redraw this and drop it down and figure out how many times 6 can go into 39. It's going to be 6 times. I multiply my partial quotient with my divisor. 6 times 6 is 36. I subtract. I have 3. And then I cannot subtract anything else from that. I look over and see that my remainder is smaller than my divisor, so I stop. However, this is not the end. This may not be lined up, so I've encouraged the students to go ahead in another spot on their paper to rewrite the numbers so that way they are lined up, because we don't want to do all of this hard work and then end up getting the problem wrong because we did not line up our place values correctly. So I will add these up, and then I have come up with 126. I'm going to move this for the sake of space, and then I have to remember I still had this 3 down here, so then I have a remainder of 3. I've also encouraged the students to make a box around their answer So that way I know where their answer is through all of this math that's on the page. And that is our partial quotient. And of course, if I want to check, I can always do the inverse operation, which would be multiplication. So I'm going to go ahead and erase this, not my answer, so I know what I'm multiplying. So what I will be multiplying is 126 times my divisor. So my quotient times my divisor, because once again, that's what we multiply, our quotient and divisor. 6 times 6 is 36. Recruit. So I have 756. Now, I have noticed in class that the students want to stop there and they're like, oh, I got the answer wrong because it's supposed to be 759 and I got 756. So I'm trying to encourage them to remember, don't forget your divisor. Because if we simply add in our divisor,